Hello, everyone, and welcome to Open Hour. I'm really excited for this month's Open Hour on air monitoring projects. We had an Open Hour about air monitoring and different types of air monitoring that were around Public Lab about a year ago, and thought it would be a great time to revisit the question. And looking around on the Public Lab site and seeing some of the people who, we've had join in the conversations going around on the list, I'm really excited to see how this call goes today. And I'm really excited to learn more and see what the updates are and see what projects people are working on, how things have changed, challenges that we've faced. So I'm very glad to have this call, and I'm excited to hear where it goes. So this call is on publiclab.org/openhour if you're watching this from Google Hangout, where there's also a live chat function. And if you're not in the live call and you're watching, there is a link to join the call live on the page. And we, I think, have room for one more person on the live call. Unfortunately, there's a limit of 10. But if you don't get in the live call or you just want to watch, that's great. And feel free to throw in questions and comments in the chat page on the Public Lab Open Hour, where you can find it on the Public Lab Open Hour page. And we'll feed those in and around the chat. So we'd love to hear from people who are watching. And again, we have room for one more if you want to join us in the call. Other than that, I'm going to leave it there, and I would love to go down the line here and see if people could introduce yourselves, where you're calling in from, and what brought you here today. So maybe we'll start here on the end with you, Chris. Can we hear you?
Can you hear me now?
Yes.
Yes, okay. I have myself muted just 'cause noise. So I'm Chris. I'm a programmer at Carnegie Mellon University, and I'm part of the SPEC project. What brought me here? I guess I was invited. So, no, but obviously I have an interest in air quality monitoring.
And for those of us who haven't heard about the SPEC at all yet, can you give us a brief intro?
Well, the idea is we're trying to make a low-cost air quality monitor, and so we're using a simple dust sensor packaged up with some smarts and some Wi-Fi and a screen, and so we've been selling them since March or so, and constantly trying to improve that. But we've been working on SPEC for about 4 years now, so it's evolved a lot, and it's been interesting. But it's, I guess, as other people know, it's a tough gig to do. It's always kind of fun to see other Kickstarters like, hey, we're going to have an air quality monitor in 6 months. Yeah, good luck with that. So maybe they will, right? But there's a lot of vaporware so far, unfortunately.
Great. Thanks, Chris.
Yeah.
Dan? Dan Beavers, I think you're muted.
No. I thought you were going down the line, and the line is different in order for me, I guess.
Oh, really? Okay. Sorry about that.
That's all right. I'm here. Well, I'm in Picayune, Mississippi, and I really don't have any more interest in air quality monitoring than my personal health. I have been interested in the technique involved in using the formaldehyde tube testing, and I've been providing some alternatives for the testing method. So that's about it.
Great. Thanks. And Don, you're next on my lineup here.
Oh, hello. I'm Don. I've been sort of lurking in Public Lab for a while, for a long time now, and I've been excited about various technologies around various monitoring things. Excited about air quality, and I have it turns out, a high school friend who works for the EPA and does air quality stuff there, and so I've been having these really interesting conversations with him about the way that they do their monitoring and all of these sort of concerns around making sure that the things that we're measuring with these technologies are actually giving us good numbers. And I know very little about this stuff, but I've just been sort of prompted and poked to be concerned about that issue. So I think that's the fun angle that I'm coming from here, and would love to hear like the trials and tribulations and techniques and approaches that people have been using around calibrating sensors and getting good data. And excited to be here. And I installed the Hangout toolbox, and now I can't access chat anymore, but I'll try to figure that out. But okay. All right, cool. Yay.
Jeff?
I'm Jeff Warren. I am on the staff of Public Lab, and I do a lot of the software stuff and some of the hardware stuff, and I've been my involvement in the air testing has been sort of in a supporting role, working with Matthew to develop some drivers for different dust monitors, so that all the different, actually a lot of the different devices that are made by people here on the call today can be connected in the same sort of way and produce a similar, at least a similar format of data, if not actually the same units, but hopefully we'll get there too. Using the OpenPipe Kit, which was developed by, actually in part by Don, and also by R.J. Steiner, who I don't think is around right now. He's actually my housemate, so, but he's not in the house at the moment. And it's like a standard set of command line drivers to connect to different types of sensors and to push them to different locations. So I'm sure Matthew will have more to say about the work we did, but my role has mostly been trying to connect up the sensors in a consistent way so that we can test a bunch of different sensors in the same environment.
Great, thanks. Matthew, are you available? Matthew?
Which Matthew?
There we go.
Oh, sorry. I have Matthew L first, but 1T. Are you there, Matthew? I'm looking at some really neat equipment. We can't hear you.
He has a whole setup, I think, that he's going to demo something.
Matthew? Do you know we're watching you?
Yeah.
Okay.
Sorry. Yeah, I know you can't hear me.
I just heard that.
How about now?
Yep.
Oh, that's great.
All right. Okay. I was setting up so that I could demo our some of the air stuff we were doing and talk about monitoring airflow. But yeah, I'm Matthew Lippincott, staff at Public Lab, and I am working on a couple different air projects. We're working recently on some of the kind of usability and design things related to formaldehyde testing. And then Stevie and I are leading a project investigating particulate monitoring. So we'll talk a bit about that as well. And I'm excited for the call. Yeah.
Cool. And Matthew S. Sorry about that originally.
Oh, it's all right. I have the whole time. I'm Matthew Schroyer. I am the founder and president of the Professional Society of Drone Journalists, and instructional technologist, and kind of the creator, developer of the Dusquino, which is a low-cost air particulate monitoring system that we're trying to design to be open source and hackable and fit just a whole bunch of different uses. But we'll get into that later today, guys.
Cool. Sarah?
Hi, I'm Sarah Longo. I work in Pittsburgh with Chris. So I work for AirViz, which works on the air quality monitor that Chris described. It's called the spec sensor.
Great. Willie?
Hi, I'm Willie Schubert. I work with the Earth Journalism Network, which is a global group of environmental journalists. I've been working with Matt Schroyer, so Matt S., on the Dustuino project, and specifically on deploying sensors with journalists in different places throughout the world on a project called Open Dust.
Great. Thanks, everyone. And if you didn't catch it, my name is Stevie, and been interested in air projects for a while now, specifically with dust, as Matthew mentioned. But yeah, so I'm just really excited to hear from everyone. So I had some kickoff questions here, but I'm really happy to just let the ball roll. And I know that some of you know each other, and I guess what I'd really like to do is hear from some of the different projects and hear some updates, and kind of give you a chance to share amongst each other and share out with other people who maybe don't know as much about these projects. So if somebody wants to kick off and talk a little bit about what they're doing and where they are in your work, that would be great. How about the spec group? We'll call on you.
Mute myself.
Hey.
Boy. You want to start? Or you want me to start, Sarah?
You can start. I'll jump in if you want.
We got a lot going on.
Me too.
I'm trying to think what makes the most sense to talk about. I mean, there's
actually,
the day-to-day
you know,
commercial side, right? But then we get a lot of questions, like, why aren't you testing for this? Or why aren't you sensing this gas? Or this and this and this, And part of the answer is, well, we want to keep it low cost. So if we throw every sensor in there, it's not going to be low cost. Part of the answer is we've not had a great amount of luck finding sensors that, even if they are affordable, even if they aren't, that they act, or they are reliable, or at least reliable long term, especially the VOC kind of things. We've done a little bit of testing. I say we, I'm a software guy, so I haven't done any hardware stuff. I just watch. But the CO2 sensors that we found are like $50 a piece. So, when you go commercial with that, it's not necessarily low cost. But, we're still trying. We're also trying to buy up or buy samples of the existing air quality monitors that are out there. So we have an AirBeam, we have an EGG, or the Air Quality EGG 2, I guess. And there's a couple others that we're about to order, we've ordered and are waiting on. Partially just to see what else is out there, but then eventually we want to have kind of a, I don't know what you call it, maybe a consumer report, just how do all these things, including the spec, respond in comparison with a MET1, with a Dylos, with a GRIM. So just to kind of see a survey of the landscape.
Great. And when do you anticipate that would come out? And is it available for the public, or?
It certainly would be. Yeah. I mean, we'll probably put it on specsensor.com. I don't think we have a time frame yet. I mean, right now we only have Air Quality EGG 2 and the AirBeam. We just got the AirBeam today. But we would certainly want to compare with. We have a GRIM that we bought. For those who aren't familiar, this is like a federal equivalency model sensor. So it's new. They're $40,000. We got ours reconditioned and recalibrated for $15,000. So they're not cheap, and they're enormous and really, really loud. But it's about as good as you can get if you want to be close to what the EPA uses. So we're going to start calibrating specs with that, and then of course we also want to compare other sensors with that and with that.
Great. Did you want to add anything, Sarah?
Chris covered a lot of what we're working on right now. I work on a lot of the outreach customer type stuff, so some of the things like working with the libraries and the the customers who order the spec through us.
We have another angle too that it's more for the I guess the corporate side of things. So big companies that have giant building air management systems that they want to get an idea of what the health of their air is like throughout the whole building. And apparently the system that a lot of them use is called BACnet. I think it's Building Automation and Control or something like that. So our hardware guy has been hooking up the spec to be able to talk to BACnet so that we can install, dozens, hundreds of specs in a building or on a campus, and they're all talking to the BACnet system. And so the folks that are responsible for those systems in these large buildings can get data not only from their air conditioning system, but also from some specs as well. So that's definitely not a consumer sort of thing, but that's another thing that we are pursuing.
Neat. Great. How about Matthew S? Do you want to give us some updates on the Dustuino and where it is and what's going on with it?
Yeah, sure. The Dustuino is, we're have done a lot since, and we documented on Public Lab a lot. But it's come a long way from its origins, which was back in about 2012, and most people involved with the Dustuino project are coming at it from a sensor journalism type angle, meaning that we want some kind of evidence-based reporting, that we can rely on to determine environmental effects. And it started pretty simple as kind of like a an add-on for an Arduino microcontroller. So this is the origin of the Dustuino. Basically, is the Arduino Uno, which many kind of makers might be familiar with. It's fairly easy to program. And once we once I got that figured out how to use that with the dust sensor and reliably send data to a service like Xively or Costum. Or what have you, I kind of then moved on to the board development phase, and this is a really crude kind of mock-up of progress of a couple of years ago, which is basically just going to a community fab lab and using a CNC routing machine to basically etch the circuit into a piece of copper there. To kind of do sort of rapid prototyping to see how that was going, and eventually we got to this, just the custom-made board, which will be distributed eventually. We're having a larger scale development or a deployment in Brazil, which I'm sure Willie will talk about that. But it's been designed so that it could work in a lot of different scenarios, at a lot of different skill levels. I've developed a cookbook of sorts that allows someone to pick up the board and program it off the bat and kind of use it around the home just to kind of see what the air is like there, compare things. But you can also do sort of more advanced things like set this up for solar power, and you can put your dust sensor outdoors. That's kind of an experimental thing we're working with, and so we're working with just a larger scale deployment in Brazil. We had a deployment in Mongolia that was outdoors and solar powered. Just kind of testing how far we can go with this and how reliable it can be outdoors for many hours. It's kind of like, to me, landing a probe on a comet or something like that, because sometimes these sensors can be thousands of miles away, and you have to do troubleshooting over those thousands of miles. And so we've really learned a lot, which will help when when the community wants to pick up one of these and wants to deploy it, we'll have a lot of answers there for them if they ever run into trouble.
Cool. Nice. Willie, you want to talk about it?
Sure. I'll add my 2 bits, and kind of going back to some of the original questions of why we started doing this. So, working with environmental journalists all over the world, there's a tremendous need for air quality monitoring. And I think there was a question that you sent around at the beginning in terms of like, well, why should we do this, and what issues have we run into, and also what kind of gaps are we trying to fill. And the communities that I've been working with in Jakarta and in Kathmandu, they're places that have specifically no monitoring infrastructure. So the status around the world in many developing countries is either no infrastructure at all or closed infrastructure that's only available to kind of a technocratic community. So you have a situation in those places where the air quality is incredibly hazardous as well, and you know, rapid developments going on in Kathmandu. You also have neighbors in India where there's huge pollution issues that are also not very well documented, and so there's just a kind of common curiosity that many journalists have and their audiences about what is the air that they're breathing. And there's, I mean, the World Health Organization has identified this as one of the lead, like specifically particulate matter, as one of the leading causes of premature death related to the environment. And so one of the reasons why we decided to look at the issue was the gravity of just the scale of the problem. The other was that there was some research that was going on. So this is 2 years ago, and it's really interesting to hear from the SPEC folks about 4 years, because we're kind of at the 2-year point, and seeing how really difficult this challenge is. We've been working with scientists who have been using optical sensors. So essentially, a small box, it's the Chinye sensor, where it beams in infrared light that scatters when it hits dust. It gets recorded on a photodiode detector and creates a reading for PM10 and PM2.5. And there was a group of academics in California and in Berkeley who kind of put this call out via academic journal and said, you know, we think that the cost of sensing is going down, and we want to know more about how communities and informal, like, participatory infrastructure projects can assist in understanding the status of the air. And the really important thing that they found was that at hourly intervals, that the data quality could be relatively comparable. So what we've been doing over the past year, just in terms of an update, is when we started this project, we were hosting all of the data on Xyblee, which is also used by the air quality egg. But you have to pay ultimately to use that or to save the data. So we've been thinking really in depth about how do you create a system where that data is actually open. And so we've been, I'll do a quick screen share if now is the time, or we can
Sure.
keep going around. Just, yeah, quick status update. So I think we ended up posting this Dustuino public lab article, I would guess almost a year and a half ago.
Mm-hmm.
And we've gone through a lot of iterations and testing, so the various different varieties, how to make one, data quality, solar power, smartphones, all of that kind of thing. And then what we've been working on now is Open Dust Map. So Open Dust Map, this is the, we've never showed this to anybody yet, so I'm glad to be sharing it with you guys. So we built essentially a system to start generating reports from the sensors themselves. So you can click on you know, seeing timescale data, all of the information starting to be recorded. Also, the ability to create keys via email to sign up so that you can start registering the device and streaming the data for free. But then also two other things. There's this one, which is after you sign up, you get an API key, a token, and you can manage your sensor, tell you where it is, give it a name, all of that kind of thing, and then all of the data is hosted in an API that you can just get all of the readings, and basically trying to document the process as well as we can, and put it into more of like a modular system so that people can also kind of copy this and recreate it for themselves. So if you want to do private deployments, that's possible. And then Matt also alluded to those kind of flavors in the cookbook, as we've started now documenting all the different code options for the actual board itself. Like the Dustarino itself is more just, it doesn't matter what sensors really attached to it. It's just, you know, Arduino derivative for processing the data and connecting it to different things. And I would say that our goal, like the next two big things that we're trying to do, one is, and this is also related to data quality. So this is AQICN. This is streaming real-time air quality analysis from official government sources. Is that for us doing outdoor deployments in cities, like trying to answer the infrastructure question, we really have to do co-location around more high-quality monitors in order to kind of handle that calibration. And essentially what we were trying to do is expand around official stations and build meshes that extend their footprint, or identify specific hotspot areas that we know, just because of the way the environment is, they're worse. Like a bus depot or a bus station in Jakarta is actually in the middle of a freeway. So you stand for 30 minutes in the middle of a freeway in traffic, you're like, that's actually going to have a much more measurable impact on your health than somewhere else. So we're still in the stage of trying to figure out a larger scale deployment, but over the past couple months, like actually last week, we signed an agreement with Seed Studio, and it's actually really apropos that this Edison AQI is also being shown at the Maker Fair in Shenzhen. But so what we've been trying to do is build kits, and I know the public lab community, like the kits are a very interesting way to get these things out there in an educational and in a justice perspective. That because when we were shipping to Brazil, we actually faced a 150% customs charge to even ship things. So it's like just finding out systems upon systems upon systems. Whether it's the actual scientific system of being able to understand what is the air quality, or the data model for how do you move that information and making it meaningful, or how do you ship things across countries. Like, I totally understand Chris's point about, how 6 months is not necessarily a realistic thing. But I think that I'm really happy to be on this call, kind of share some ideas with all of y'all at the different stages of our maturity levels.
Wow. Thanks for sharing that. That's awesome. Your site looks amazing, and I was so excited to see that map. That's really cool.
Yep, that's the first one. We got one. We're going for one.
That's awesome.
40. Yeah, there's 40 more down there, actually, that we have to get hooked up, hopefully, in the next 6 weeks.
Wow. Wow, that's cool. Yeah, and if you guys have questions or comments I'm not, streamlining this, so please feel free to, share or ask questions as we go through these. So, Matthew, do you want to talk a little bit about what you've got going on there?
Yeah, so I thought I would give an insight into some of the work I'm doing and the intersections of different projects. As I mentioned earlier, Stevie and I are working on a dust sensing project, and then I've been working on some design issues on the formaldehyde testing, along with Nick Shapiro, and he's really the lead on that, and then also Jeff and Gretchen and staff at Public Lab. And So those two things, the dust monitoring and formaldehyde monitoring, have intersected at the issue of, how do we calibrate DIY devices, and how do we actually know that we're getting good airflow? And that issue kind of has cropped up both in the DIY dust monitoring and in the formaldehyde monitoring. So in the dust monitoring, I bought a Thermoscientific PDR 1500, which is like a kind of industry standard, retails for $6,000 optical particulate monitor. And its biggest selling points are that it was factory calibrated, that it has a pretty reliable pump to move a very consistent amount of air. It also has a series of devices called cyclones and other things that can mechanically separate different levels of particulate matter, so that you can weigh a filter with those particles and calibrate after the fact. And that, I'm sure that the spec team can talk more, but that contrasts to a design of a low-cost device, the spec or the Dylos, which is here, both of which use a computer fan for airflow and a Shinye, an optical sensor in the case of the Dylos, as Matthew Scheuer had talked about earlier. And so there are a couple ways that a lot of the DIY sensors are moving away from some of the different design patterns and more expensive systems. And I'm kind of wondering about the reliability of those.
Matthew,
am I in demo mode? I'm in demo mode. Oh man, my camera.
There's some really dramatic effects going on.
This is great. All right. How about now? There we go.
That's better.
Okay, so
we had like FIFA, we had the whole thing.
Just 50 seconds. Sorry, it was confusing.
So yeah, I was wondering how I could measure and so with the Shinye and DIY dust sensor development, there have been different people who've posted different claims about airflow through low-cost sensors. So people just studying the raw Shinye sensor, hooked up here, which just uses like thermal conduction to move air through the, and it's a pretty slow airflow rate and very susceptible to, air blowing around and wind and other issues. The computer fans seem less susceptible to that, but how could we, could we see if wind events show up? Like, are these usable outside? Like, those are all questions that are open. And so I was interested in how I'd monitor airflow. And going through this question in the public lab community, David Mack, who's a user, has been very helpful in this. Dan Beavers, who was on earlier, has been very helpful. And we looked at different methods we could monitor airflow. So I had two questions. What's the actual airflow of a device like the spec? How would I measure that? And if I was building something, a low-cost sensor, what's the best airflow method for running through a Shinye? And then also, how do we calibrate one of these DIY formaldehyde tests? Because Nick had come up with that same question. What would be a low-cost calibration for formaldehyde testing? So I'll digress from air testing for a second and introduce the formaldehyde stuff, and then I'll go back and talk about airflow. So this is the version of the DIY formaldehyde testing kit that I put together for myself, and it's just, this is an aquarium pump. This is to Nick Shapiro's instructions. It's an aquarium pump with a little valve to control flow, and I'm using this bottle as a stand, and this takes these little formaldehyde testing tubes, which stick conveniently in a stopper, and then in an ideal world, our pump is going to pull exactly 0.3 liters of air through per minute for 30 minutes, so that exactly 9 liters of air are exposed in this tube. We can then measure, there are little measurements along the tube, and it changes color. This tube's been exposed, but it would normally be a pink to orange gradient. So this is the setup that Nick had come up with, and we were wondering, well, how can we help people calibrate these? The valve Nick was using is this. It's a rotometer. So it has a little tiny bead that hovers to tell you the airflow. But the accuracy of this device is a $90 device, and its accuracy is plus or minus 5%, which is, and that's in ideal conditions. And ideal conditions are quite hard to achieve. If you look at it from the side, you'll notice that that bead floats a good deal away from the sides of the device. And yet we have to take a measurement from the widest point on this little tiny floating bead in relation to these different marks. So not only is this airflow, is the rotometer plus or minus 5% in terms of airflow calibration, but then there's a significant human error in terms of its function. I also discovered in testing that if you stuck it on top near the pump, the vibration of the pump would change the reading, and then also if it, it's how vertical it is could also change the reading. So we were asking questions like, if we ship these around to people in a DIY situation, how do we know we're getting the airflow we want? And we were looking at some other methods, and David Mack suggested using what I've been really fond of, which is measuring the flow of a bubble down a graduated cylinder. And incidentally, that is almost the exact same method that the EPA reference method uses. So this is a NIST, this is a traceable calibrator for airflow, and it was about $1,000. And all it is this tube has an automated bubble thing. You click here, and so it makes a bubble film that goes onto the bottom of a tube. And then a little bubble travels up the tube, and there are two different electronic infrared sensors that measure at two different points and time the transit of this bubble through the tube. And so knowing the volume of transit plus the time, you can calculate airflow. Well, it turns out that you can do the same thing within 1% of accuracy with this $5 graduated cylinder and some soap bubbles. And so that was kind of the method that I've been using. I'll demo it here with our pump. This may get a little loud.
Oh, I see. So you make a soap bubble in the bottom.
Yeah.
Okay.
So I'm waiting for the sides to kind of get covered with soap, but you can see that there's this soap bubble, and right now it's traveling kind of crookedly because the sides are unevenly greased down. But the speed at which it travels, I can then use a stopwatch to time the start of a bubble forming. This is my popper for bubbles. And so that has allowed me to do a really accurate calibration of these different air pumps.
A demo,
although slower than. Oh man! Oh, the mirror to cool. Okay. Someone can figure out how to get Canon cameras not to go into demo mode when you don't put a tape in them. I'd like to know. Yeah. So you can get very good accuracy. I just did a video on that, a YouTube video you can watch if you'd like. I'll drop it in here. Doing calibration. But then for testing the other air tools, I was wondering, like, how could I do the same bubble method with a meter like the Dylos or something? And so I tried just chopping the bottom off of a graduated cylinder. It was totally hollow. So a 1 liter. This is a 1 liter graduated cylinder. And I tried rubber gloves. Condoms turned out to work really well. So I would wrap a condom around the airflow meter and attach it to, and cut the other end off and wrap it around this graduated cylinder. And then I could draw an air bubble up the cylinder and time its transit, which allowed me to figure out at least the flow of the Dylos and the spec. And much like the spec team, we also have a air casting device arriving soon, so I'll test that when it arrives. Yeah, so that's the thing I'm most excited about, and I'll answer some questions about airflow and pass it on for now.
Cool. And I also just wanted to mention that on the IRC chat, we have a friend who's named Albert here, if anybody's watching it, and he's sharing out work that he does on this website, conundra.info. And I haven't had a chance to peruse it yet, but it's a carbon monoxide focused. So just wanted to share that out as well. Then I will post it on the chat page on the Google Hangout, and also check it out. I'll share the link at the end of the call when we post the page down below on the Open Hour. But so there's some other people here thinking about some of these other issues and wanted to share that out too. Yeah, and he's having trouble joining the Hangout otherwise. So, great. Well, I would love to open the floor. You know, there's a lot that's been shared. And does any, have questions for each other, or comments, or feedback, or ideas about, problems that you've heard people talk about, or successes that you've had? I'd love to just open it up for people to have a conversation about any of those things.
Can I start?
Please.
So Willie, I would love to have an in-depth conversation afterwards or some other day about data repository. We had to solve this exact same issue for SPEC and other environmental sensors that we have from the Create Lab. And I imagine we probably had a lot of the same motivations and pains as well. I mean, we looked at Xively, we looked at all the other expensive like Cloudant, and they do awesome things, but they do awesome things for 10 grand a month and up, right? And that doesn't work in academia. So in the end, we ended up just building our own. So I'm excited to see, you guys have something that looks kind of similar, REST API, map kind of stuff. So there's probably a lot of similarity.
Yeah. I'm
just kind of throwing that out there. So.
Yeah. Yeah, and that's one of the things that would be great before we go to talk as well. I had sort of like the wrapping up questions here is like, how can people collaborate on these projects? And I guess like I would throw out obviously the suggestions of the Open Air group on Public Lab, but also the idea that we've had this happen in an Open Hour before, where there are these great ideas that need more time to share and a more specific like conversation. And there's a function here that we can do a call specifically for certain ideas. And that's just really easy to set up. So that would be awesome. And then if you guys have other ideas on sharing and collaborating on any of these projects. Did anybody else have comments or questions?
I just also wanted to add to the issue of the data repository, because that was a really kind of important issue, in developing this whole thing was where do you put it? A long time ago, if you had an Arduino and you wanted to, store that data from a sensor, on the internet where anyone could see it and where it could be graphed and look great. I mean, we used to go to a place called Pachube or Pachu, whichever way you pronounce it, and then that changed to Cosm, and then after Cosm, that got changed to Xively and bought up by a company called Logmein, which changed its strategy to become more of an IoT company, Internet of Things company, rather than a kind of a hacker-friendly place to post your data. And now you see places like SparkFun kind of getting in on the data repository game. Really, I mean, it was simple to choose a sensor off the shelf because there were a few choices and they were all getting cheaper and better if you knew what to look for. It was relatively easy to build because of all the code and schematics available online because of open source. But the real challenge did become like where do we put this stuff? Who owns it? Which is actually kind of a pretty big issue. If you're in some kind of sensor journalism initiative where potentially someday, you're collecting this data that people are offering. Do they know where it's being kept? What kind of agreement do you have with people giving up that data? But I mean, the ownership issue is huge, and so sometimes you do have to set up your own system you know, to store it, to graph it, to export it, to whatever you need to do. I'd say, you know, more than, you know, figuring out what components to put on the board, it was about, you know, the quality of the data, the format of the data, and, you know, where to send it and how to send it.
Yeah, I'm also interested to know from Matt and also the group, because the spec uses a fan and regulated airflow going into this low-cost sensor. And one of the things that's really been driving us is how do we keep the price down as much as we can so that it's affordable to as many people as possible. And, you know, I'm just wondering, in your guys' opinion, is there a place for, like, a medium accuracy device that's low cost, or is that just, you know, clouding the issue more with bad information? Or, like, do you see that there's a space for something that isn't of regulatory accuracy but also doesn't come with regulatory price tag?
Speaking for spec, we certainly hope so. Putting on the commercial hat, right?
Right.
You know, it's tough because when we talk to the EPAs and other folks who have a BAM or a GRIM or these, you know, federal monitors, and they've done some testing, right, with ours, the old version of the spec, the black one, and they come up with numbers like, well, you know, there's no correlation whatsoever. And then here in Pittsburgh, so the Allegheny County Health Department, they have, you know, a bunch of sensors all around town. One of their buildings has a BAM and a GRIM on the same roof, and they don't agree with each other. So if they can't agree, I mean, how does anybody have any hope of agreeing? So I guess our answer would probably be, sure, as long as the low-cost sensor can be shown to correlate with some sort of reality, you know, preferably some sort of professional-grade monitor. You know,
Right.
if you just take like a Chenier sensor and put it out in the sun, you'll get all kinds of great readings, but it's garbage, right? Because it's just light getting into your sensor. So, you know, as long as the work has been done to hopefully prove that you're measuring something real, sure, I think there's value. But at the same time, you know, EPA has said to us, you know, we don't really know how to deal with people saying, hey, my spec is reading hazardous, what do I do?
Mm-hmm.
You know, it may just be the sensor's broken, or you know, something's going on in the house. You know, EPA is not going to care about that or be able to do anything about it. So I think walking the line of giving people information, but also with the, you know, Hitchhiker's Guide, don't panic, because it's really just a tool to spur you to investigate. It's not really to, at least that's how we're building the spec. I don't think anyone should take a spec and, if it's reading high, you know, immediately panic, saying, you know, I'm going to die. There's something terrible going on. You know, you may have just cooked some bacon, or vacuumed with a terrible vacuum that's, you know, putting out more dust than it's sucking up.
Right.
So I don't know if that's a good answer, but I think that's how we would probably feel about it.
Well, let's not underestimate the hazards of cooking bacon.
Right.
It's full of nitrosamines from the nitrate preservatives, plus all the oil compounds. It's actually pretty bad to inhale bacon fumes.
Matthew, I'm going to have to ask you to put $1 in the tangent jar.
No, I wanted to do a more direct follow-up to, I think, what Chris was saying, which is, you know, I've been wondering about this question of where do optical monitors fit? Because the type of sampling, the mechanical sampling that the EPA does is very expensive. You know, and yeah, $15,000, as Chris said, for used equipment, plus all these lab tests of each filter after 24 or maybe 72 hours. And so I wondered why the optical monitors haven't fit into the EPA plan until now, because several have been around for now like 20 years on a commercial basis. And I'm not sure the EPA is going to make space for the optical monitors as a regulatorily actionable measurement, but I think that they're probably going to become or they are becoming the means for determining where to stick some sort of mechanical sampler.
Yeah.
One thing we're looking at, and in the early stages of developing a partnership around, are doing passive monitoring with either scanning electron microscopy or optical scanning of a small passive air plate. And I have a little summary of a process that started at the University of North Carolina. I just dropped it into the chat. And these samples over the past 12 years have been tested and to correspond and at least meet EPA reference method specifications when analyzed correctly. So they aren't yet a reference method, but they're within spec for doing EPA reference method measurements, and it's a physical measurement of a particle. I wonder, yeah, with the optical measurements, the one note I saw from the EPA was they'd really like to see a local correlation, which is not just a gravimetric calibration, but also, you know, one of these calibrations against some sort of physical sampling method. And so I'm thinking, I think as optical imaging systems get better and cheaper, we'll be able to use a lot more of these passive methods to get more accurate data out of our optical sensors. And so I'm really interested in investigating not just this one, but other passive methods that we can use for getting a little tiny filter and or collection plate and scanning it.
Yeah.
I'd love to take a moment here and thank Albert for joining us. I know you had some trouble getting on the Hangout, but I did want to hear a little bit from you, and I shared with the group in here and on the Public Lab page the website that you posted, and I would love if you could introduce yourself and talk a little bit about it.
Thank you. Can you hear me?
Yes.
I'm an environmental health engineer and toxicologist who's been working for over a decade with people who suffer from chemical sensitivity disorders and hypersensitivities to chemicals in their environment. That got me interested in monitoring gases in both air and breath, and for the last 15 years I've been trying to find partners interested in these dual-use applications for sensors such as CO, NOx, hydrogen sulfide, oxygen, CO2 that in the right range can measure meaningful numbers in both inhaled ambient air and our exhaled breath. That's CO most importantly, but all the others are important as well. And multi-gas sensors are available now in the range of a few $100s that combine 4 to 6 sensors. But the least expensive option that I'm hoping someone can help me hack into are $5 CO, NOx, metal oxide sensors that are in HVAC air inlets of cars with electronic climate control. And the sensors are controlling the opening, switching it from fresh air to recirculate whenever high levels of gasoline or diesel exhaust are detected by the CO and the NOx sensor, respectively. They're designed for 10 or 15 years life on the road and very robust. Unfortunately, none of the data are collected. They just go to the control board in the automobile and nowhere else. And I'd like us to find a way to get those data out and map them. EPA has never asked for them. They're potentially useful not just for local governments and federal governments to map pollution, but I'm hoping someday there would be mapping overlays of mobile sensors the way we have traffic overlays on weather maps. So anyway, I'm interested in working with groups who have access to sensors in the suitable ranges, and I was a little disappointed to see that some of you are using CO sensors that don't go low enough for breath, or CO2 sensors that don't go high enough for breath. And it is a problem to find dual ranges for some of these, but the value is great, and it really is meaningful to people to see the correlation between these gases, either indoors or outdoors, in air and in their breath. For instance, just to leave you with an example, people who live with gas ovens or ranges that have standing pilot lights have breath carbon monoxide levels that are 5 to 10 times higher than people who don't, in the same range as people who smoke but who haven't smoked for a couple hours. So we can also see elevated breath CO in many diseases, as well as natural conditions like premenstrual syndrome and even during pregnancy. So it's not a unique marker. None of these are. The information that's useful would come from monitoring many gases together and interpreting the pattern. I guess the odd gas or the odd sensor out here is particulates. We really don't have a use for particulates in exhale breath, but all the gases are useful. Anyway, that's my pitch, and I hope I can work with some of you in the future on this. Thank you.
Wow, thank you. Thanks for sharing.
Sure.
And just, I think it was maybe missed a little bit, or we haven't talked about it on this call, but oops, I'm gonna just mute you because you unmute yourself, but I think, there, that's better. There was an echo there. Last year, actually, when we had this call, there was a good bit of conversation about sulfur dioxide sensing, and you can go back and watch that and see a little bit about some of the projects that were on that. And they're on the Public Lab Wiki as well, if that's part of, you know, what you're interested in too, and maybe a bit more advanced than where that was, but there's some really interesting project updates that have happened for that over the past year as well. So thanks for coming and for sharing, and I'm sorry you had trouble earlier, but I was really excited to see your site and hear about some of the work that you're doing. So we have a few minutes left here, and I just want to say I'm happy to keep the Hangout open, but I know that there are people who you know, leave us on the hour. So if anybody has wrap-up comments or questions that you want to get in before the hour's up, just to plug it in there so that we have the full audience, now's a good time. Otherwise, thank you everybody for joining, and I will leave it open.
I was wondering, since we were talking about repositories for monitoring, if Jeff could talk a little bit about OpenPipe Kit. If I can put you on the spot, Jeff, if you're comfortable doing that.
Yes, but I am one of these people who has to go, so I will try to say that in like a minute. Actually, Matthew, you want to paste that into the IRC chat, because I think...
I got it.
Okay. So I'm only like a contributor to OpenPipe Kit. RJ, who I think is in the IRC chat, or was, is I think the original creator, and there's other people who've contributed to it, including Don Blair, who's on the call, so they can talk about it perhaps in more detail. But I think we
just say that last part again.
Oh, but they may be able to talk in more depth about it. What I've done is I'm like at this point I think I'm the person who's written the most drivers to conform with the OpenPipe Kit standard. Because Matthew made me do it. No, because we've been working together on this dust tracking stuff. So basically, OpenPipe Kit uses the Linux or the Unix pipe to pair two drivers. There's a pull driver and a push driver. The pull driver pulls from any sensor according to the standard spec that RJ has proposed. The push driver pushes it into any data storage system. So that could be, right now, primarily like Fant or other online databases. I imagine someone will probably write one for Xively or whatever. But it might also be like an SD card or something like that. And the idea is they run on a Raspberry Pi, typically, although I've been just running them on my computer. And you plug a sensor in, and then you pull from the sensor, and you use the pipe character, and then you push to the server. And you run that, and you can run it like every minute or every 5 minutes or whatever. And the gist of it is that most of the drivers I wrote, I just took an existing driver. Like I think I did one for the spec, and I did one for the... I think I did either for the Dustuino or I just did one raw for the Shenye. But I did it for a bunch of these different devices, and the Dylos and the Thermo Fisher that Matt has, and each of them gives a certain formatted JSON string, and then they all go into Fant, because I just use the Fant driver as the standard one. I'm about to send an email to the air quality list, the PLOTS air quality list, proposing that we write a Fant push driver, or sorry, an OPK push driver to go to the Open Dust Map, because I think that's a great place to put things, and that has a map built in and all kinds of great stuff. I didn't know about the serial driver for Dustuino, so actually I'm remembering, so I had only written a driver to pull from the Chenier directly, but using the Dustuino serial, I can pull directly from the Dustuino as one of the pull drivers. So it's a really neat way to just make sure that everything's consistent and it all like can plug in any which way without having to think about it. So I gotta go. That's actually the doorbell, and I'm gonna. Thanks very much, everybody. I'll send this email before I sign off. Right? Bye bye.
Thanks, Jeff.
On the spot.
Did anybody have anything else? Any other comments, questions? One thing that was shared out on the IRC chat here was just kind of exactly what Jeff said, and he's going to do it now. But continuing conversations and ideas and questions can definitely happen on the air group, on the air quality list on Public Lab, and that's just at publiclab.org/lists. You can find all those, and then yeah, it would be really awesome to see some of these things that people shared here. I'll post them with the Open Hour, but just as research notes for updates is a really cool way to hear about the things that are going on and to share and collaborate in that way. And you can co-author research notes, wiki pages with other people as these things develop. And to co-author, this is a kind of a newer function, but the research notes, you just tag the person who you want to co-author with. So if you guys are sharing back and forth on certain projects, either one of those would definitely work. So did anybody else anything else? There was an awful lot of really great, awesome information that came fast right away and then moved on to something totally new. So it was a lot of high level conversations. So if anybody has some of those deep diving questions, I'm happy to leave this open.
Well, I have not so much a question as just a, I think I need to stand up for Bacon's honor there from Matthew. But honestly, I mean, one of the first things I did when I built my first dust sensor is, I did cook some bacon in the house because I knew that was going to generate a lot of, oils in the air and things like that. But kind of a serious question to Matthew, is there value? And you mentioned there's chemicals in that air. Do you have anything on that bench that could potentially tell us what's in that? Because we've been talking about dust sensors this whole time, and particle counters. And the EPA standard is a mass measurement as opposed to a particle count. Is the next step in this kind of trying to find out the content of those particles?
Oh man, that would be cool to do for cheap. I haven't seen anybody who can. That's my simple answer. There are a couple limited assays I've seen for doing some specific chemicals can be identified by the shape of their particulates, by when they're either scanned in an electron microscope or something. But all of the dichotomous sensing that the EPA likes seeing, where they collect it on a filter, that filter gets dissolved, and then all of its contents run through X-ray spectroscopy or mass spectroscopy or something to identify what's inside. And yeah, that's what the EPA really likes. That is really expensive. It's $60 a test or something to run. So I don't know.
All right. Anything else, anyone? Great. Well, thank you all. Chris, did you just unmute? I'm watching.
Yeah, I was just
Okay.
Go ahead.
Great. Well, thank you so much, everybody, for joining. And this was really awesome to hear about all these different projects. And I'm excited to see maybe some thoughts and sharing of collaboration that can come from this. Yeah, don't hesitate to reach out to each other. And this Open Hour is also will be hosted publicly on the OpenHour page, so others will watch it in the future. And so to have a place where they can look at your projects available is great. I'll share the links that were shared on here, so if you have any other links that you want posted with the Open Hour, put them on either chat and I'll collect them all. But great, thank you, everybody.
Thanks.
Thank you.